We continue with the LP model implementation with spreadsheets rather than the more complex mathematical, or in case of just two decision variables, graphical formulation, however useful these were in explaining the underlying concepts and logic. We're going to switch to the second standard solver sheet in the Excel file, shown right here. I'm going to zoom in a little bit. Here we follow the model structure and notation from chapter 13 in the textbook, which is generally in line with the accepted principles of spreadsheet design for optimization models. The top red section right here of the shows or consists of the available data on marginal profits and costs, as well as labor and material availability. So the marginal profit right here, marginal requirements for labor and material in the matrix here, and then the availability of labor and material is right here. Okay, you can kind of see that these cells B7, C7 are equivalent to vector C from the mathematical formulation. The range B4 to C5 is matrix capital A from that same math formulation, and the cells D4 and D5 are vector B from the same formulation. So the middle blue section right here contains the core part of the model, with decision vector X equals X1, X2 in range B11, C11. And the formulas for calculating marginal costs are going to be in range B12 through C13, as well as those for the total resource used here in D12 and D13. Okay, the marginal profit contributions will be calculated in these two cells B16 through C16, and finally the total profit will be calculated in this cell D16. Right, all the equations are pretty straightforward, so let's just show an example. Right, when we have 1 pound of drug 1 and 2 pounds of drug 2 produced. Generally, when you're developing formula, you want to have some values other than 0, 0, and then you want to return back to the 0, 0 before you actually run the model, as you'll see later, right? So the labor required to produce 1 pound of drug 1 is B11, or 1 pound, times 4 hours, right, in B4. Okay, resulting in 4 hours of labor. And then if I copy that to the right, it'll give me 6 hours of labor for 2 pounds of product 2, because it's 3 times 2 is 6. And then if I've actually locked in B11 before dragging it over there, I could just drag it down and have 1 pound time of material produced for drug 1 requires 1 pound of raw material, so that's 1 times 1 is 1, and then to produce 2 pounds of product drug 2 requires 2 pounds of raw material, which makes it a 4, right? So the total resources used were just 4 hours plus 6 hours, 10, which is feasible, and then copy that down. 1 plus 4 is 5 hours, which is also feasible. Both are under 12 and 6, 12 hours, 6 pounds available labor and material. The marginal profit contribution of producing 1 pound of drug 1 times $2 is obviously $2, and 2 pounds of drug 2 times $3 is 6 for the total profit, which we know from the previous video is suboptimal $8. I'm just going to save that. Okay, so overall, the decision variables, okay, X1, X2, drug 1, drug 2, 1 and 2 pounds currently, right, should be sort of, standing out on their own, right, clearly labeled pounds of product produced, drug 1, drug 2, right, and highlighted somehow, like with this box here. Okay, all the data, right, decision, variables, intermediate calculations, all of this should be labeled properly and highlighted accordingly, right? So this is sort of showing how how that's done. Okay, I'm going to save this. I'm going to zero these guys out temporarily, okay, and just leave the formulas and switch back to the presentation, okay, which sort of emphasizes all the stuff we just talked about, right? Um, Grouping them together, data towards the top, clearly labeling decision variables using descriptive labels for constraints, and emphasizing the objective functions to objective function to be optimized. Okay. So in our manual, solving LP by hand approach, we already discussed the feasible suboptimal solutions as well as the infeasible ones. So for example, we know that x1, x2, as we just showed in a spreadsheet model, is a feasible solution, but suboptimal. And then, for example, x1 equals 1, x2 equals 3 pounds, we know already from previous video that it's infeasible, and it's easily verifiable by substituting 1 and 3 here, right? We don't have, we're 1 labor hour and 1 pound of raw material are short, so this, unattainable profit of 11 should look familiar from what we had before. Okay, so based on this simple two product mix example we keep following because it's a good sort of learning tool, it may seem that finding the optimal solution is a simple task, right? Because there are only a couple of constraints. There's really three vertices that matter, right? The 0, 3, the 3, 0, right? And then the optimal one, 1.2, 2.4. But in reality, for a more complex model, the task of finding the optimal solution is really, could be really difficult. You have to be able to imagine problems, real problems, right? With hundreds, even thousands of variables, okay, and dozens to hundreds of constraints. Finding an optimal solution, assuming one even exists, is a complex task. As such, it requires special algorithms and software, one of which is presented next. The Excel has a built-in solver and then its premium solver counterpart. Both are solid optimization engines capable of handling problems of decent size and scope. They would not be probably appropriate for the most complex of scenarios, but for our purposes, they will do just fine. Both are available as Excel add-ins. The built-in solver is available with a standard version of Excel, whereas premium solver comes with the entire analytic solver platform we've seen and we've been using pretty much since the beginning of the class. As the current screenshot shows over here on the right, you need to use Excel options add-ins and then check solver add-in for the built-in solver and then analytical solver platform, right? So this is the built-in solver, this is the analytical solver platform, which should already be checked because we've been again using it since the beginning, right? And this one is going to show make the premium solver available for you. So to show that in Excel, okay, you go to again File tab, Options, Add-ins, click on the button Go, and you'll get the Add-ins dialog box, right, where both solver add-ins should be checked as well as the analytic solver platform. I can cancel that, go back here, right? So